So this is the easy method for doing method of joints for solving a framework. I have a framework on the screen. First thing to do is to take moments and solve for the reactions. Once we have our reactions, we can then redraw the frame with gaps in each members so that each of the joints is separate. For this method, we take all the members that are on an angle and break them up into vertical and horizontal components. So for each of these, draw the components, but do not overlap them with the members that we've already got. Now we'll take this left hand joint. If we have 5 down, then we must have a force of 5 up in order for my free body diagram. So this must be 5. 5 is up. The other component must be in this direction since we're adding nose to tail. In terms of the angle of the frame in here, we can get that off my original. The angle in here, tan theta, is equal to opposite side 0.5 over the adjacent side. So my tan theta is equal to 0.5. We're going to use this later. My angles for my frame in here, we know that we've worked out the tan of that. Tan theta is equal to opposite, which is 5 over the adjacent side. Since we know that tan theta is equal to 0.5 in this case, therefore A must equal 10. So this will be 10 in here. Both my components are going up, nose to tail, so this will be going up. My verticals, I have 5 down, 5 up. Horizontally, I have 10 going to the right, therefore this must be 10 going to the left. This is now a complete free body diagram. Everything adds up to 0. I can now transfer my forces to the other end of the members. This is 10 going to the left, therefore this must be 10 going this way. Both my components of this one are going up, therefore this one will be going down. These will therefore be going this way. This will be 5, this will be 10. If we look at this joint, we'll find that we don't know enough about that joint yet because there's too many unknowns. So we'll go to this joint down here. If this is 10 going to the right, then this must be 10 going this way. If this is 7.5 up, then this must be 7.5 going down. This is 7.5 going down. This has to be 7.5 going up. If I now look at my vertical forces, I have 5 going down, 7.5 going up. This must be 2.5 going down. This is the angle of my frame in here. Therefore I know that tan is opposite over adjacent, and that must equal 0.5. Therefore this member here must be 5 kilonewtons and going to the right. If I now look at my horizontal forces, I have 10 going left, 5 going right. This one here must also therefore be 5 going to the right. So I now have 10 to the right and 10 to the left. So now we just continue this process on. Transfer your forces from one end to the other. That's all the forces on my frame. We can now look at the tensile compression of each one. For this member, arrows are pointing inwards, so this is in tension. Arrows are pointing outwards, this is compression. This one will also be compression. In terms of member sizes, obviously the force in this one is 10. The force in this one will be the square root of 5 squared plus 10 squared, which will come out to 11.1 kilonewtons, and we just continue that process on through all the members.